Today, I will work through the construction of a line segment with a length of the square root of 11 inches. This construction is credited to the mathematician Theodorus Spiral, so it's known as the Theodorus Spiral. I start by measuring out 1 inch using my ruler. Note, this is the only time in the construction where I'm actually using the marks of my ruler. For the rest of the construction, it serves merely as a straight edge. I start by constructing a right triangle with leg lengths of 1 inch. Using an arbitrary length, I mark 2 points along the first line, equidistant from one of the endpoints of the 1 inch segment. Then I extend my compass to a wider length and draw arcs above the line using the 2 equidistant points as my center. Using their point of intersection and the endpoint of the 1 inch segment, I connect a perpendicular line, creating the right angle for my right triangle. Now I set my compass back to the 1 inch and mark that distance as the leg length on the new perpendicular segment. I can now connect up the hypotenuse of my right triangle and calculate its length using the Pythagorean theorem. I know that each leg is 1 inch, so a squared plus b squared is 1 squared plus 1 squared, or 2, and the length of the hypotenuse c will be the square root of 2. To continue this construction, I begin a recursive process of constructing right triangles with a height of 1 inch and a base of the previous hypotenuse. Here I'm constructing the next right triangle, which will have legs of 1 and the square root of 2. So using the Pythagorean theorem, we can calculate that square root of 2 squared is going to be 2, plus 1 squared will get us to 3, and then the square root of that will be our hypotenuse length, so the square root of 3. And as this process repeats, each triangle will have a hypotenuse that is the square root of the next whole number. So a note about the hypotenuse, which we talk a lot about in this construction. The definition that we're used to working with is that it's the side length that falls opposite from the right angle in a right triangle, but this word is actually derived from the Greek hypotenusa, which translates to stretching under. An interesting way to visualize the connection between these definitions is to draw the right triangle so that we can see the right angle on the top, and the hypotenuse appears to stretch under it. Now, back to our construction. I've moved ahead to the final triangle of our construction. You can see how this pattern has repeated and brought us around in this gorgeous spiraling pattern. It's a very satisfying construction, and I hope you try it out. And here we have it. The hypotenuse of this final triangle is going to give me that goal length of the square root of 11. Thank you. Hope you enjoyed.